Hello everyone, hope you are having a good time at the GIDS. I am Vinay Joshi, Senior Director, Data Engineering from Target. In the year 2018, as data became more central to our business, we started to look at why our data couldn't be used effectively for decision making. So, even though we have several petabytes of data in our big data environment, so we proposed a new and a structured data platform architecture called Analytical Data Platform, and that's what I'm going to talk about today. In the next 20-25 minutes, I'm going to delve deeper into what were the symptoms and the underlying problems that led to the development of this architecture. Also, the challenges we faced while building this architecture. And I'll also talk a little bit about how we are managing and maintaining our platform, and did we manage to prove our initial hypothesis, and how do we see this architecture is evolving. So let's dive into the symptoms. This must be a familiar slide to most of you from the data world. I mean, how many times you have searched for a data set and have found many candidates. In this example, I have searched sales data set, which is the most important data set for any organization. I mean, our business depends on this data. Finding a data set is like finding a needle in a haystack. Additionally, if you have multiple copies of the same data, it becomes all the more difficult. So if you are lucky and are able to find a needle in a haystack, there is no guarantee that it's the right needle. Our Slack channels are constantly buzzing with questions such as, this data in this report does not match with the data set in the big data environment, or a particular metric in one data set does not match with the same metric if it's calculated in another report. I mean, clearly they are using the wrong needle. That's a wrong copy of the data. So if you are lucky and find the right needle in the haystack, you may have to join that needle with another needles to make sense of it, which means users may have to write complex joins before they can meaningfully use and consume this data. Again, this must be familiar to most of you. I spoke about some of the symptoms in the previous slides. Back in the day, when we moved from RDBMS to big data world, traditional constructs like normalization were carried over, which resulted in significant consumption overheads for our users. And all of us from an ETL background knows that it's so difficult to manage thousands of ETL jobs. And at the same time, there is not enough transparency to our users on what is really happening inside the pipeline. Every other day, we used to get litany of complaints from our users related to data quality. So we looked at these symptoms and categorized them into 3 problem areas. Specifically, how do we need to curate our data? How should we maintain it? And how should our users consume this data? So let's look at what the solution. Defining the problem clearly led us to these 4 objectives. We were very sure that we wanted a consistent data architecture, a common vocabulary, a governed program to put controls, and pre-joined domain-centric data sets to reduce consumption overheads for our users. Based on these objectives, we have come up with the Analytical Platform architecture, which has 3 main components. Atomic history, as you see in the bottom of the layer, is where the raw data from different source systems is landed. This raw data for a specific domain is cleansed, transformed, and enriched, and we build core histories. So core histories is a single view of the specific domain. If there is a data needed from different domains, then we join those domains and we build aggregates. Along with this structure, we have also put some access controls. While our scientists and analysts can have a direct access to these data sets, all the tenant applications and the operational systems, if they need analytical data, they would consume this data only through an API. So all this, besides this structure, helped us to put some process controls. Any data set that we build that follows this structure and also meets required engineering benchmarks and data documentation standards, that data set was deemed certified and usable for enterprise. And all this was a cross-functional effort, including our consumers, to make sure that there is a broad enterprise buy-in to use this structure and the change management that this structure would entail. So as we defined the architecture, we wanted to look at how we need to build it. I don't expect you to read this slide. This is a code snippet of a Hive SQL that was used to build a legacy pipeline. How many of you have seen this kind of a code before and have wondered how is it really working? So this surely couldn't be our approach. So what was it? So before we started thinking about the technology we need to use to build our architecture, we defined the objectives, principles and concerns a ETL pipeline should satisfy. I'll pick up few of them just to explain our thinking. Reusability. We wanted all the common functions to be created as a library, and that library should be reusable by any dataset. Consistency. We wanted all our pipelines and datasets to be built in a standardized and a consistent way. Expressive. We wanted a fungible talent pool, so our pipelines needs to be more expressive. Maintainable. Any engineer can maintain any pipeline and also should be able to extend the solution if it needs be. Because in the legacy world, the engineers are tightly coupled to a pipeline. If a particular engineer has built a pipeline and if some defect comes and you have to maintain that pipeline, only that engineer is the right person to do this. Observable. Legacy pipelines are not observable. So we were very sure that all the pipelines should have a level of observability, and we wanted to provide that transparency to our users on what is really happening inside the pipeline. So based on these objectives, principles and concerns that we have defined, we created a pipeline development framework named Kelsa. Kelsa is a Kannada word for work. Kelsa enabled the development of the certified datasets in a more standardized and consistent way. And it was easily accessible by multitude of users across the enterprise. And by focusing on how of the development and standardizing the repeatable tasks, as you can see, Kelsa gave back precious problem solving time back to the engineers. Moreover, Kelsa provided standardized observability and data lineage that really helped to provide the transparent view to all the data consumers. So we have defined the architecture and we know the technology that we need to use. So the immediate question for us was, do we have the required skill set to build this? Our engineers have primarily worked in data warehousing and they were experts. While this gave them deep insights into data design and domain understanding, but clearly it was not enough to migrate them to a modern tech stack, because they have primarily worked in SQLs, which has a procedural paradigm, whereas modern tech stack demanded more of an object-oriented paradigm. Modern concepts like observability and testability were not well understood. And as I touched upon previously, there was a tight coupling between the pipelines and the engineers. As we all know, SQL doesn't lend itself to collaborative development. So there's a tight coupling. So these were the challenges that we immediately encountered when we started thinking about it. So clearly, we wanted to equip our engineers with skills and confidence to execute this. While Kelsa took care most of the heavy lifting, our engineers could use their domain expertise to write atomic functions, which actually helped them increase their familiarity with the language. We strategically placed some of the external hires to drive hands-on Spark Scala certification and solve real-world use cases. At the same time, we also built a culture of innovation within the team and conducted hack days to instill confidence and curiosity within our team members. And last but not the least, we also opened up our Kelsa platform so that engineers who are getting skilled in the language, they can also meaningfully contribute back to the framework. So with this, we gradually transitioned our team members from a legacy platform understanding to more of a modern tech stack. If the previous slides would have painted a rosy picture, let me tell you the journey was not without its bumps. And we encountered multiple problems along the way, and I would also touch upon how we navigated those challenges. As we were doing the re-platforming exercise, our business also grew by 40%, which resulted in explosion of data volumes. There were fine-grained operational processes that also made the matter worse. And we had finite compute resources, and under stringent SLAs, we have to ensure the pipelines are getting processed. We had data quality and observability in the pipelines, but those were not standardized. Each and every pipeline were adding data quality checks the way they wanted to do it. The observability was not standardized. Source system standards. They were not clearly defined once because the standards were not defined, so that some of the quality issues from the source system could percolate to the pipeline, and the pipelines have to maintain and fix those issues. So clearly we wanted to fix that part of the world also. So this is where product thinking helped us and our focus on learning and development. With the 50 days of learning and 50 days of tech paradigm that Target provides to the engineers, engineers got the required space, time, opportunity to solve these problems. And to solve the problem, as I spoke about the explosion in data volumes, the team came up with layered parallel processing framework, which uses the patterns in data to massively parallelize the processing. We built a data quality framework and standardized the observability at central place. History restatement framework was developed. So history restatement is one of the common problems in data warehousing world, wherein for different reasons we have to go back and correct the history. So imagine a data set with billions of records. We have to correct the history maybe 10 to 12 times a year for different reasons. That's a very costly affair. So here team came up with a configuration driven history restatement framework, which not only helped us deliver, process the history faster, as well as it does not require any engineer to babysit those pipelines like we used to do in the earlier world. What are the other tactics that we have used to accelerate our journey? We majorly focused on our product thinking and framework based thinking, not only for technology innovation, but also for process innovations. We use the same processes of product thinking and framework based thinking the way we ran our engineering operations, whether it was using data analysis to do the right prioritization, the way we should build our data sets, or building automation tools like XDiffer that we have built that reconcile the history of migrated data, or reconcile the accuracy of the migrated data. So this product thinking not only helped us in technology and these kind of innovations, but also in process innovations, as I spoke about, like Palooza Day. We came up with this new concept of Palooza Day, wherein we provided dedicated space, time, and opportunity to our team members to work on a specific problem for a specific period of time with a clearly defined objective to accomplish. So as we continue to build data sets, we also realize that the balance has to be shifted to improve our engineering operations. So the first thing we did is we stood up a data site reliability engineering team that focused on improving the reliability and the performance of the platform. We defined clear data governance policies to ensure that data is managed through a clearly defined data lifecycle process. Strong observability, including effective monitoring and an alert system. So with these, we were able to manage and handle the needs of evolving business requirements, thereby continue to support our operations. So here are some of the outcomes that we have achieved during this journey. The major one, as you can see in the middle, 90% reduction in data sets. Since we denormalize our data sets, we reduce the redundancy and the duplicated data sets in the legacy environment. We reduced our whole footprint by 90%. So clearly our maintenance overheads from engineering was drastically reduced. And as you can see, 55% reduction in the number of joins. So our users who used to write complex joins before they could meaningfully use the data, it is drastically reduced. So instead of looking at where to find this data and write those complex joins, they are now able to focus on solving business problems. And our pipelines are performing much better in the newer world. We have 75% reduction in the history restatement effort. History restatement should go anywhere between 1.5 weeks to 2 weeks. Now, most of the pipelines, we can do a history restatement in around 36 to 40 hours time frame. So those are the benefits that we have seen. So we started our journey with a concrete problem statement and hypothesized a solution. In the journey, we have also seen significant outcomes, but we wanted to look back and then see, did we really succeed? In principle, the analytical platform architecture proved to be the right one. However, there emerged certain scenarios wherein we have to work around these principles to solve that. I'll take an example to explain that. As I was saying that while we were doing our replatforming, source was also getting modernized. So what happens if we actually rebuild the data set and source is also modernizing? Once the source is completely modernized, we have to rebuild it again, and it will be a throwaway work. So to avoid that, we actually came up with a lift and land strategy, wherein instead of rebuilding it, we just lifted the code base from one platform and landed it to another. While the frameworks helped us in accelerating our build, our operations were still federated, which resulted in lack of systemic governance. And as we look at these problems and the way we are thinking our architecture should evolve next, we found that we thought that we need to really go beyond frameworks to centralized platforms. This will enable us to democratize the data set creation with minimum standards of build, quality and governance. We'll centralize the data provision of our data sets that will simplify the access for both human and tenant needs. So as one journey ends, another begins. Isn't this the life of an engineering team is all about? Thank you for your time and attention.